So from that model, we can do some statistics. We have a model for that was derived in terms of expected returns, but we could also look at this as a model of R. In other words, imagine that we did the same derivation for gamma, but thinking of gamma as a random variable, where instead of alpha, we use a random variable R. We would then get that gamma as a random variable is omega times the random variable R minus R plus R. So we have omega here. So as a random variable, the return, on the option is the elasticity times the R is the random variable and little r is the risk-free rate. So from this, I can calculate the expected value of gamma, and that's the formula we had before. The expected value of this random variable is omega times alpha minus r plus r, using expected values. I can also calculate the variance of this random gamma and calculate the standard deviation. And when I calculate the variance, I get omega squared. When I calculate the standard deviation, I get the absolute value. So it says that the volatility of the option is the volatility of the stock times omega. So in our example where the volatility of the stock is 30%, we would multiply that volatility by around 4 for those call options we saw examples of earlier, and it would be more like 120% would be the vol of the option. The risk premium is, again, easy to calculate. Remember the definition of risk premium. It's simply the return minus the risk-free rate. Using that formula, the risk premium of an option is omega times the risk premium on the stock. And then finally, the Sharpe ratio. Recall that the Sharpe ratio is by definition the ratio of the risk premium to the volatility. The general measure of the Sharpe ratio, we'll see this in a later module, we'll do more work on this. It's basically, you can think of it for the stock, it's alpha minus R over sigma. So the Sharpe ratio for a security is the expected return minus the risk-free rate, which is the risk premium, divided by the volatility. And so we can see that the Sharpe ratio for the option is in the numerator we need the risk premium, that's the omega times alpha minus R. In the denominator we need the vol, and that's the stock vol sigma times the absolute value. So this gives you plus or minus the Sharpe ratio for the stock. Because notice that we can cancel out the omegas, but we get a plus or minus because of the absolute value. So what we conclude is that for a call, omega is positive, and we use a positive, namely that the Sharpe ratio for an option is the Sharpe ratio for a stock. But if we're dealing with a put, the Sharpe ratio for the option is minus the Sharpe ratio for the stock.